Okay, hi everyone. We're going to talk about functions and graph today. This is section 1.2. I'm going to guess the notes are going to be a little bit longer. You might want to break this down into two pieces for yourselves, but that's completely up to you. Okay, so we are going to talk about functions first of all. Now, functions is something I did not understand very well as a student until I began teaching it, and I really feel like it's an important thing to understand. Basically, a function, when it says is a correspondence, it's like some sort of rule, like something happens. I call it a machine a lot, okay? And it takes things in, and we call those our input or our domain. And a lot of times that's our X values, and it does something to it. And then whenever it does, it shoots something out. And what it shoots out is what we call the range or the output. And a lot of times that's what we call our Y values. And functions are different than just relations. Relations are just ordered pairs, random ordered pairs, like you did in elementary school where you would draw the pictures and it like maybe would be a pumpkin at Halloween time when you would connect all the dots. That's just a relation. There was no real pattern to it. A function is somewhat predictable because what happens with a function is if I plug, for example, the number 2 in to a function and it shoots out the number 5, then later, if I plug a number 2 in, it still has to shoot out the number 5 because this machine turned all 2s into 5s. When we had that relation, I could have 2, 3, and 2, 4 on my pictures, and that 2 shot out a 3 here and a 4 there. That's not a function. A function is somewhat predictable. Okay? So some things are functions and some things are not. The way we can tell if it's a function is to just check the x's. Each x can only have one y. So if it says 2, 5, 3, 7, 2, 5 again, and then 4, 9. This would be a function. You can't even tell that's a 2 because this x goes with that y. So 2 goes to the 5, 3 goes to the 7. Okay, oh, here's a 2. It has to go with 5, and it does. And a 4 goes with the 9. So the only x that repeated was the 2's, and it was a copycat, so it's fine. Now, if it was 2, 5, 3, 7, 2, 7, 4, 7, this is not a function. The 2 goes to the 5. That's fine. The 3 goes to the 7. Here's the 2 again. We already said the 2 has to go to a 5, and now it goes to a 7. That's not okay. This 4 goes to the 7 is fine, but this is what's not okay because the x2 has 2 different y's. So each function, each x has one y. So let's look here. We're going to figure out if this is a function or not. So this -6 shoots out a 36. So does the 6, and that's fine. So you have -6, 36, and 6, 36. Then you have -3, 9, and you have 3, 9, and you have 0 go to 0. Each x only has one y, so this is a function. Even though the y's repeat, that's not a problem. Only the x's can't repeat. Okay, so a relation, like I said, is any ordered pairs, and functions are special relations. The domain is what goes in, the input. Domain is x most times. And range is what y is most time. Now, I have a way for kids to remember this. Domain is x, range is y. If I started singing right now randomly, home, home on the range, what would you guys be saying right now? You would say, why or why is she singing? Why is she singing home on the range? Why am I stuck here? Why is she so weird? Why does she sing home on the range so bad? Because range goes with y. Okay, so you'll remember that. Or else I'll sing it to you and you'll love it. Okay, so let's see if this is a function. And then we're going to find the domain and we're going to find the range. So is it a function? Let's see. 9 goes to -5 and then 9 goes to 5. This is not okay. If it's a function If I plug in 9 and it shoots out a -5, then it always has to do it. Now, a 9 came in a +5. That can't happen. So this is not a function. Now, it's just a relation. In its domain, I think the way they're going to have you do this is they're going to have you do a forehead, nose, and chin for a little brace here. And I think they just want you to put 9 for the x value. There's another 9. And then a 2. Another forehead, nose, and chin. And then the range, ooh, that was a little squiggly, will be -5, 5, and 4. You should be able to tell that this couldn't be a function because there were 2 arrows coming out of that 9 if you were going to draw the arrows like that last example. Let's try this one. Is this a function? -2 goes to the 5, 5 goes to the 7, 0 goes to the 1, and 4 goes to the -2. There's no repeating. So every time I plugged in a -2, it shot out 1. This shot out 1, 1, and 1. This is a function. The domain will be those x values, -2, 5, 0, and 4. I don't think you have to put them in the correct order. And the range will be 5, 7, 1, and -2. Okay, so that's domain and range. Is this a function? -5, 0, and 6. Yep, none of them repeat. The -5 shoots out a 3. The 0 shoots out a 3. And the 6 shoots out a 3. That's okay. Actually, I can tell what this function is even doing. This function is turning everything into 3s. And that's fine because it is predictable. So the domain, it is a function. The domain is -5, 0, and 6. And the range is really small this time. It's just the one element, or 3. Okay, so function notation. We use this function notation like this: f of x. And that's how you read it. F is the name of the function. So like for my machine picture, this guy's name would be F. X is what I'm plugging into it. That's your input, whatever's in parentheses. And then the whole entire thing is what it shoots out. So F doing something to X, or F of X, is the whole thing. And a lot of you say F of X is the same thing as Y, because when we graph it, we usually graph X and then we graph F of X, which is the same thing as graphing X and Y. So the function's name is F. X is called the input, and then the whole thing, F of X, is called Y, or the output. So here are some examples. If this is the function, so this function f, what it does is it takes 2 times the number and squares it, then it subtracts the number and adds 3. That's function f. When I plug 0 into this function, what happens? So the way we write it is we take out the x and we put in the 0 in parentheses. The parentheses will be very important, especially in a problem I'm going to do in a minute, which is very commonly missed in Algebra 2 and Algebra 3. So 2 times 0 is 0, minus 0 plus 3. If you plug 0 into this machine, and this is function f, it's going to shoot out the value 3. My drawing is like so garbagey. You're probably judging me. That's supposed to be like a funnel. Can you tell? Okay, -7. What happens if I plug -7 into this guy? Well, I'm going to take 2. The parentheses are important here because when you square -7, that's going to become positive. So be careful there. And this will be 2 times 49 plus 7, because minus and negative is positive, plus 3. So this will be a calculator problem for me. 2 times 49 plus 7 plus 3. And 108 is what's going to come out every time I plug in the -7. Oops, that's what I wanted, 108. I think the black marker is a little negative. I'm going to go to purple. That might make me better. Okay, let's try purple for a bit. Okay. Now this guy. This is where it gets really tricky. So you have that function f, right? And it took 2 times that value squared minus that value plus 3. So if I plug 5a into it, I'm going to take out the x and I'm going to put 5a in parentheses. You are going to have to do some order of operations here and be really careful. I'm going to get A's in my answer. I'm not going to get a number here because I'm plugging in an A. I'm going to get an A out. So I'm going to take 2 times. If you take 5A times 5A, that's actually 25A squared minus 5A plus 3. 2 times 25A squared is 50A squared minus 5A plus 3. That cannot be simplified any further. So when you plug 5a into that function, it shoots all of this out. Okay, now this is the one. If you're going to listen to anything, listen here. This is the one. If you plug in a minus 4 into this equation, you're going to get 2 times a minus 4 squared minus parentheses a minus 4 plus 3. Now, there are all sorts of places kids are going to make this mistake. We're going to do this problem probably at least 10 to 15 times this year, okay? First, when you have a minus 4 squared, so many kids are going to tell me that it's a squared plus 16. They're going to do this. That is so wrong. No. A minus 4 squared is the same thing as a minus 4 times a minus 4. You have to double distribute. So I'm going to expand this out. I'm going to write it 2 times a minus 4 times a minus 4. I'm also going to distribute this negative a right here. Minus a plus 4, and then you still have the plus 3. I'm going to save this 2 for a minute. I'm going to bring that down. And I'm going to double distribute this. A times a is a squared. Then we have a minus 4a. And you have another minus 4a plus 16. So this guy is what the a minus 4 times a minus 4 is. So that's a squared minus 8a when I put those two 4a's together plus 16 minus a plus 7. Almost done. I have to distribute the 2 and then combine my like terms. This is really tough math right here. So this is 2a squared minus 16a plus 32 minus a plus 7. And then you have like terms with the a and the numbers. And my final answer is 2a squared minus 17a plus 39. I'm pretty sure you guys are going to want to come to office hours and work a couple of those problems together. That's going to be the most commonly missed problem this year. Okay, so what's next? Graphs of functions. When you graph them, I mentioned this, you graph x and then y, or x and then f of x. We can use our calculators to help us. You can use t-tables. On this one, I'm going to go ahead and have you use your graphing calculator. You would just type y equals x squared minus 5. So x squared minus 5. If you hit graph, it's kind of hard to see what's going on. But if you go to second graph, that's your table, it will give you some nice points to plug in for your graph on your math lab. Or you could have known that it's just a downshift of 5. This guy, also we can use our calculator. Y equals x cubed minus x. Y equals, it'll be x caret 3. Hit the right arrow out of there, minus x. When you hit graph, you can kind of see what it looks like. If you need to go to second table for some better points, that's fine. But do you see all these zeros here in the middle? You might want to go to second table set, which is your window. And you might want to like start at -1. And instead of going by ones, maybe go by 0.1s. And you can go back to the table and you can get some of those in between points that might help you. That might help make your graph a little better. Because I'm going to go back to that. Sorry. You can tell it does go up and down a little bit in there. How about this one? How do you graph it? It'll be the square root of x plus 4, y equals, clear this out, second x squared, and it should grow with me. Some of you at the older versions will have parentheses there. If you have calculator questions, you're going to have to come to office hours and ask me that too. X plus 4, hit graph. Okay, it's like half of a parabola. If you go to a table again, you can get some nice points. I'm going to go to second table set, go back to ones so that I can see it better. And 5, 3 is a decent point. There's 0, 2, and that can help you a little bit. Okay, so when you look at a graph, how can you use function notation? Well, if this is my graph and they're asking you for f of -3, they're saying x is -3, what is y going to be? Well, if f is -3, that's right here, the x is -3, the y value goes over to 3. So f of -3 is 3. If they ask you for f of 1, they're saying x equals 1. What does y? Well, here's where x equals 1. Where does it equal y? Right here, f of 1 is -5. If I ask you what f of 0 is, that says x equals 0. What does y equal? Well, x equals 0 right here. Y would be -5. So whatever's in the parenthesis is the x value, and we were looking for the y value. Okay, vertical line tests. This is a way that you can check to see if a graph is a function. Go back here. This guy is a function. If it had the machine and the ordered pairs, we would have to check each ordered pair to see if each x was shooting out one y. But there are infinitely many points to check here, so we can't check that. So what we can do is we can check them visually with a vertical line. If I had a sideways parabola, when I plug in 0 here, I have 0, let's say that's 2, and I have 0, -2. This is not a function because this value of 0 is shooting out two possibilities. It fails the vertical line test. A vertical line will hit a graph only one time because I'm checking each x to make sure it only has one y. So that's what the vertical line test does. If it's a function, vertical line test says if graph is a function, a vertical line will only hit the graph once. It is the exact same thing as checking the x's. So let's check these real quick. Is this guy a function? Well, let's check these x's. Is anything hitting it twice? Nothing's hitting it twice. That is a function. Is this guy a function? And the answer is no, because at this particular value, there are 3 different outputs. It is not a function. Same thing here. It's shooting out 2 values almost everywhere, so it's not a function. More practice. What do you think? Function or not? That's a no. Here, it's good here. It's good here. This is a function. This one is a little tricky. This piece is a function, but what's happening here? This is a solid dot and this is an open dot. It's only hitting it once, and it's hitting it once here. This is a function. Okay, the last thing we're going to talk about today, I believe, maybe not. Yeah, I think so, is this idea of domains of functions. This is a really big idea. Okay, here's what I'm going to tell you. We're going to make this up our own way. Okay, when you have your function machine, what can I plug into here? That's my question. What is the domain? What can x be? Okay, we assume the domain of a function is all real numbers. And we can say that like this, either negative infinity to positive infinity, or you can say a double bar R. This is what your math lab is going to want. Okay? The only time it's not is when there's restrictions. The domain has restrictions if there are what I call risk factors. Okay, so what are these risk factors? You will know this by the end of the year. There are really just two risk factors that you need to know about. Number one is dividing by zero or fractions. If the equation has a fraction in it, there is a risk factor because you cannot divide by zero. The only other, that's not what I wanted, right? The only other risk factor that you will experience a lot this year is a square root of a negative. You cannot have a square root of a negative because that would be imaginary. So you're looking for even roots, which will most of the time just be square roots. You cannot have a negative underneath there. If there is a risk factor, then we have to look more closely and we have to see what would break the machine. Okay, so for example, if my function was 1 over x, I can plug anything I want into this machine, except there's one thing that will break it. If I plug in 0 into this machine, I would have 1 divide by 0, and then the world ends. Like it's a really bad deal. And it breaks the machine. So this has a restriction. X cannot equal 0 because it has a risk factor. Now, if the equation was just 2x plus 3 and I look at it, there's no risk factors. There's no division. There's no square roots. So the domain will be all real numbers because there's no risk of this machine breaking. The only machines that could possibly break are the ones that have fractions or square roots. So let's look at this guy. They want to know what the values are of the function. They want to know what f of 1 is. Can I plug 1 into this machine of 1 over x minus 3? Sure, I can. I take out the x and put in a 1. 1 over 1 minus 3 is 1 over negative 2, or negative 1/2. So the point 1, negative 1/2 is going to be on this graph. So 1 is in the domain. It is one of the things it can be. Can I plug in 3? Well, if I plug in 3 into this machine, what happens? I'm going to get 1 over 3 minus 3, which is 1 over 0. And you cannot divide by 0. So that's no. You cannot do it. 3 is not in the domain. We say x cannot equal 3. 3 is not in the domain. It's the only number that would break this. And you should have known there's a risk factor because it looks like a fraction. So when it looks like a fraction, what you can say is, oh dogs, this guy cannot equal 0. And you could have figured out x minus 3 cannot equal 0. And then you would have known that x cannot equal 3. You will have lots of practice with it. That's going to cause you some questions here at the beginning, but you will get better, I promise. So look at this guy. Is there a risk factor? And the answer is yes. I cannot divide by 0. So this guy cannot equal 0. X squared plus 2x minus 3 cannot equal 0. So what do? I have to figure out what would make it 0. And the way you will do this, it's been a long time. How do I figure out what x is? You would have to factor it. So we will factor this, x and x. If you make a list for negative 3, I have to get to positive 2. 1 and negative 3 gives me negative 2. It'll be negative 1 and positive 3. x minus 1, x plus 3. Those two things cannot equal 0. So what would make it 0? Well, x can't be 1 because if x was 1, it would be 0, and x cannot be negative 3. Now, on my homework, on paper, you can write it like this. Your math lab for the domain, it wants to know what can it be. So when you say what it can be, you're going to say, well, it can be negative infinity, and it can go all the way to the small number negative 3. Then you'll put that together with the small number negative 3 all the way to 1, the big number, and then from 1 to infinity. So it skips over negative 3 and it skips over to 1. You guys will get good at writing this notation eventually, but this is going to be really hard on your homework. You're going to have lots of questions about that, and I'm going to help you. Okay, so we'll get good at it by the end, but that's going to frustrate you on your first homework. Okay, next thing. Look here. Is there any risk factor? Is there dividing by 0, any fractions or any square roots? No. So this domain has no risk factors. It's negative infinity to positive infinity. Does this guy have a risk factor? It has a cube root, but cube root of negative numbers are okay. The cube root of negative 8 is negative 2. It's fine. So this also has no risk factors, and because of that, when I ask you the domain, it's negative infinity to positive infinity. Okay, so domain on the graph is what x can be. Range, it's what y can be. You're talking your left and right and up and down. Here's more notation. If this is your graph, what is the domain? This one has a risk factor, guys. X plus 4. X plus 4 cannot be negative. So x plus 4 has to be greater than or equal to 0. When you solve that, you would subtract 4, and x has to be greater than equal to negative 4. The only things I could plug into this function machine are numbers that are bigger than or equal to negative 4. So we say that it's from negative 4 to infinity. You could graph it to do that, or you could have solved the equation, had a risk factor. For the range, you would go ahead and graph it. The range is going to come from the graph, and you would look, and it bottoms out at 0, and it goes up forever. So the low number is 0, the positive number is infinity. Last things here, they just want to know domain and range, I think. Yep. How about domain and range here? Let's do domain first. Any risk factors here? No, that'll be negative infinity to positive infinity. This guy, does it have any risk factors? No, that's also negative infinity to positive infinity. Does this guy have a risk factor? Yeah, you cannot divide by 0. So x minus 2 would be dividing by 0. So that guy cannot equal 0. And you would add it, and x cannot equal 2. So the way you would say that in math lab is you would tell me what it can be. It can be negative infinity to 2. Then it skips over 2, and it goes to infinity. Okay, and then this last one here. This one is hard, actually. I don't even want to do it. I'm not going to do that. Skip that one. I don't want to confuse you at the very end. As far as the range goes, you would go ahead and graph it. Here's the first graph, the up or down. The range on this one is also negative infinity to positive infinity. The range on the x to the fourth one here, I don't know if you can see it. It looks like it bottoms out here at negative 4. It can be negative 4, so the range will be negative 4 and up forever. It's always small number to big number. And then on D, the one that we skipped here, where the can't divide by 0, it does go down forever and it goes up forever, but you see how it skips right here. So the range for this guy will be down forever, then it stops at 0, then it skips over 0 to infinity. I anticipate you having lots of homework questions. So I think we're going to do the homework questions on Friday in the class time for any of the classes. I'll list all the possible classes for Algebra 3 homework questions, but you're probably going to want to go do some of your math lab with me on Friday. If not, you'll be able to catch it up with office hours on Monday as well. Okay.